Okay, everybody, this is Chapter 8, Section 2, Special Right Triangles, a really big concept that you really have to get down. Not too tough, but it does take a little, study time. Make sure you're going back and looking at it. Some other math classes you'll take after this one will use this specific section a lot in what they're doing. So make sure you get this down and make sure you have some time to keep looking at it so you have it pretty down. Okay, so special right triangles, you guys could write that title down. And special right triangles are, first off, they are right, but they're specific ones, and there's only two, so it shouldn't be really that hard to remember this. Okay, let's get to, I'm going to go pretty quick through the video, so if you're getting behind on the notes, just hit pause and get caught up, okay, and then go back and hit play. All right, so the first one that we're looking at is a 45, 45, 90 triangle, and so if you guys would, draw this particular triangle and label it up. This actual triangle comes from a rule that we learned in the first semester, talking about angles and their opposite sides. Okay, so special right triangles have a relationship between all three sides of a triangle when it's a 45, 45, 90, and then the next one we look at is a 30, 60, 90. These are only two that have some real specific relationships that you can use and not have to use like Pythagorean theorem or something else to find angles or side measurements. Okay, so one thing we did learn was that when you have two angles like this, they're both 45, we learned a while ago that the opposite sides should be equal. So we don't know what the measurements are, but x equals x, and that follows the rule that we learned a while ago. Okay, but the relationship now would be that whatever the leg is on a 45, 45, 90 triangle, and these are legs, okay? Whatever they are, I could just take it and multiply it by the square root of 2. Okay, so it's kind of a number that you would use all the time, no matter what. It's just a square root of 2. Okay. So my example would be, if I told you that the leg is 6, well, that means that this is going to be 6 also, because they're supposed to be equal. But then the rule here, so in the theorem, the hypotenuse is the square root of 2 times as long as each leg. So you'll see this x right here. The x is the leg. Excuse me. The x is the leg, and so I just take it and multiply it to the square root of 2. And in these, we're always leaving the answer as a simplified radical. Okay, so that's pretty straightforward. How do you do this thing? Okay, so I'm going to give you that, but we're going to have to learn something else that goes with that when I'm given the hypotenuse and I got to find a leg. That's where it gets a little bit difficult. Okay, the next one that we want to do is 30, 60, 90. Okay, so if you could go ahead and draw up this triangle and label that up. And this one has a little bit more that we have to kind of remember, and we have to be able to understand the relationship between the three sides. Okay. So in the theorem's kind of too wordy for me, and you got legs and hypotenuses and longer legs and shorter legs, and it gets kind of confusing. So I think the picture is a little bit more understandable, and I'm just going to have you understand that the shorter leg is kind of like the key. Everything kind of runs through the shorter leg to help me find the length of the long leg and the length of the hypotenuse. Okay, so first off, always make sure you identify the hypotenuse. It's across from the right angle. Okay, the other thing we learned a couple chapters ago, first semester, that the shortest leg is always going to be across from the smallest angle. So in this case, 30 degrees is the smallest angle. So the opposite side, we're going to call it X. Okay, that's going to be the shortest side. If you go back and read the theorem, it says that the hypotenuse is 2 times longer than the shorter leg, or twice as long. So you're just basically doubling it. So that's where you get 2x. The x represents the short leg, okay? And I'll just double it to get the hypotenuse, all right? The one that will kind of confuse some students is that you're going to have then a relationship between the short leg and the long leg, okay? And the long leg is the square root of 3 times as big as the short leg. So like kind of like the 45, 45, 90, I'm going to take the short leg, whatever it might be, and multiply it to the square root of 3. Okay? And so let's just do a real quick example. Let's say I give you the short leg as 4, and I'm going to ask you to find the hypotenuse. Well, the hypotenuse is, double the short leg, so it would be 8, right? The long leg is square root of 3 times bigger than the short leg, so it would be 4 square root 3. Okay, so not really difficult stuff. It just sometimes we overthink this one because it's really different, kind of weird. Just got to remember the theorems and be able to do that. Show the relationship between the 3 sides. Okay. All right. So, the problem here is that we get these two kind of mixed up. We forget what we're supposed to multiply it by and whatever. You got to find a little trick to remember it. So remember when I was a kid doing this, in a 45, 45, 90 triangle, you had 2 angles that were 45 degrees, and I would take each one and multiply it by the square root of 2 to get the hypotenuse. So since I had 2 45-degree angles, I'm multiplying by the square root of 2. That's how I remembered it. For the 30, 60, 90, I had 3 sides that were all going to be different, so I remembered to use the square root of 3 when I was using that particular theorem. So that's, you come up with little tricks sometimes to remember it so you don't get screwed up. Okay. All right, so we're going to go down here, these examples. Why don't you go ahead and draw them. You could hit pause and draw them all in, and then I'll start working on the solutions. Okay, so you can hit pause, and then when you get it all done, hit play, and we'll do the solutions. Okay, so you're identifying in A, you're identifying what kind of triangle it is. You've got 2 to pick from. All right, you got that, or you got this. 2 special right triangles. Okay, so 45 degrees obviously is going to tell me that this angle down here is 45, and I'm using that 45, 45, 90 triangle relationship. They give me a leg, and this leg should be the same as y, so y should equal 3. All right, and then I'm going to take that leg. It doesn't matter which one. Usually the one that's given to you, but they're the same, so it doesn't matter. And I got to find the hypotenuse. Well, I'll go back to your relationship. The hypotenuse is a square root of 2 bigger than the leg, so I'm just going to multiply them together. Okay? We're going to leave it that way. When we do these, you're going to leave it in simplified radical form. You get in some other math classes, you're always using these ratios anyway, so I want to make sure we got that. Okay? I'm going to go and do D first, just because it's kind of sticking with a little bit of what we did. Identify the triangle you got. Well, I got one angle that's 60 down here, so that means this would have to be 30. So I'm using the 30, 60, 90. Identify the side that you have. This is the hypotenuse, okay? Now, most of these problems, I like to use the term we're going to work this backwards, okay? Because if you remember what I said, everything kind of goes through the short leg, but I don't have it. But if you go back to the theorem, the short leg and the hypotenuse had a pretty easy relationship. I just doubled the short leg to get the hypotenuse. Well, now I have the hypotenuse, so how do I go backwards to get the short leg? Okay, so I was multiplying the short leg by 2 to get the hypotenuse, so backwards would be dividing the hypotenuse by 2 to get the short leg. So 22 divided by 2 is 11. Okay, and now that I've got that, I got to find the long leg. Okay, and the relationship there was to take the short leg and multiply it by the square root of 3. So I would just, put them together basically. Okay. So that's more of what you're going to have to do is kind of move stuff around and remember the relationships. We're saying you multiply them, but there's going to be times you're going to have to do that backwards because you're not really given that specific one that the theorem is based on. So you're going to have to do some division to get it to go backwards. Okay. So let's look at B. Okay. This is a really good one. We have to remember some of our radical rules and remember that I'm kind of working backwards. First off, this should be a right angle right here. So that's telling me that's the hypotenuse. Okay. So what they're asking me to do is find the legs. Now, how do I know it's a 45, 45, 90 triangle? Well, because these two legs are equal, then that means that these two angles, if it's a right triangle, that these both have to be 45. Okay. All right. So that's just knowing some other rules that we've had before. We got to do that. Now, what the issue here is that they're giving me the hypotenuse, and the hypotenuse is the square root of 2 times bigger than the leg. Well, I got to go get the leg now. So I want to take the hypotenuse and divide it by the square root of 2. Okay. Because remember, I multiplied the leg by the square root of 2 to get the hypotenuse. So whatever that number was, it gave me 5, but now I got to use it to go backwards. So if you remember your radical rules, I can't leave a radical in the denominator because I'm dividing it. So to get rid of it, our rule was to multiply the top and bottom of the fraction by the square root of 2. Okay. So multiply straight across, I'm going to get this. Okay, and the square root of 2 times the square root of 2 is the square root of 4. You multiply it like regular old numbers. But what is the square root of 4? It's 2. Okay, so that's going to be my answer for each of the legs because they're supposed to be the same. Okay. Well, you have to be good at that. That's more of what you have to be able to do with these ratios. Okay. The other thing I just want to point out, it doesn't happen in this problem, but I'd want to look at these two numbers. Can I reduce them? And I can't. So I'm just going to leave it as a simplified radical. Okay. So we have to really be good about doing that. Okay. Let's look at C. C is pretty similar to B, where I'm going to have to work a little bit backwards. I can tell this is a 30, 60, 90 triangle. I can tell that this is the short leg. So it's X, and I need to find it. I'm going to understand that this is the longer leg and that this is the hypotenuse. Okay. So sometimes you start doing these, name the sides or understand different things so you can understand how to kind of proceed. All right. So if you remember, I'm going to draw this over to the side so that we can kind of have it. It was the relationships for this in a 30, 60, 90 triangle. Okay. So I've got the long leg and I need to use it to go get the short leg. Now, if you look at my example here, I multiplied the long leg, or the short leg, I'm sorry, by the square root of 3 to get the long leg. Well, how do I go from the long leg back to the short leg? Okay, so I want to undo the multiplication. To do that, I divide. So some of you guys are going to divide it by the square root of 3, which is how I'm going to get there. Once again, by doing that, I can't leave it in that form. So I'm going to get the radical out of the denominator by multiplying both the top and bottom by the square root of 3. So multiplying across, I get 5 square root of 3. Okay, and then the square root of 3 times the square root of 3 is 9, but the square root of that is 3. Okay, so that's going to give me my short leg. Okay, now I use the short leg to get the hypotenuse. If you go back, if you got the short leg, I'm going to multiply it by 2 to get the hypotenuse. So I'm multiplying this by 2, and that's going to get me 10 square root of 3 over 3, okay, for the hypotenuse. So these B and D are ones that hopefully take really good notes, write everything down, and those two you need to study, besides understanding the ratios from the theorems that we gave you, okay? And like I said, you're going to hear me say it a lot when we do these. You got to work it backwards sometimes. And what I mean by that is you're going to have to divide by those radicals that are in the theorems, okay? So make sure you kind of understand that. Please, like I said, go back and study. It's not hard stuff, but it's different, and we gotta get it down. Okay. So if we go down to these other examples, kind of using these to be able to get different things. Okay. So let's go ahead and draw those. You can hit pause again, draw them, and then once you're ready to go, hit play. And I'm just going to get going. Okay. So in example 2, they want me to get the area of these. So for the first one, it's a triangle. So let's first off, to get the area of a triangle, we use this. Okay. Now, this question, first one, we have to infer something. If they give me this as being 6, they're really saying that all the sides are 6. Okay. So we'll go ahead and do that. So that gives me my base. So that's half of what I need for my formula. The other thing is that we learned this in a different chapter too, that if all the sides are the same, then all the angles should be the same. You know, if all the angles are 180 together, then they should all be 60. Okay, so this is 60 up here, and here, and here. Okay. All right, so I need a height. So what I can do is I can go here from the top and just draw straight down and get a vertical height that'll be at a right angle. Okay, and then now I got to find it. How do I do that? Well, what happened is that up here, when I drew in that height, I split that angle, and so now that angle became 30 and 30. So that leaves me then with a 30, 60, 90 triangle, and I can use that to get what I need. Okay. So this, what happens down here at the base, I split it in half, 3 and 3. So this side right here becomes the short leg. I'll use the triangle on the right. That side becomes the short leg because it's opposite the 30-degree angle. And that will then allow me to get the long leg, which is really the height. Okay. So if you go back to your 30, 60, 90 relationships, I'm going to take the short leg and multiply it to the square root of 3, and that will give me the long leg, or in this case, it's the height. Okay. So this is a classic problem. This one you will see again on a test. You'll also see it in other classes when they do some different stuff. So, that one's going to show up a lot. All right. So now I have my base, which was 6. I have my height, which is 3 square root of 3, and I'm dividing it by 2. That's how I get the area of any triangle. Okay. So multiplying the top, 6 times 3 is 18, square root of 3, divided by 2. Okay, and then I can reduce these two, and that gets me 9 square root of 3 for my area. Okay. So really, you're leaving these in a simplified radical form again. It's a really good problem, shows up all the time. Okay. If you look at B, I got to get the area of this parallelogram. So remember, it's this, the base times the height, or you go length times the width, but this one really should be a base times height because they're giving me a vertical height right here, okay? So I know that my base is 5, okay? But my height can't be this diagonal length here, okay? So what I'm going to have to do is, since they kind of gave me a clue, that's a 60-degree angle, so this is 30 degrees. So I've got a 30, 60, 90 triangle out here on the end, okay? So if I look at that, that 4 should be the hypotenuse of that right triangle, okay? So I'm going to have to go from here and get this little piece right there. So remember, the hypotenuse is double the short leg, so I want to divide it by 2, and I get 2, okay? Now let me back up or stop for just a moment. One thing I think I kind of failed to mention before, when you're working on a 30, 60, 90 triangle, the short leg is kind of like the key. It goes, you have a relationship between that and the other 2 legs. There is no real relationship straight away between the hypotenuse and the long leg, okay? So that's why I went and found the short leg, because I'm going to use that now to go find the long leg, but I can't go like from hypotenuse to long leg or long leg to hypotenuse directly. Everything has to go through the short leg, okay? So I'm going to take the short leg. If you go back to your ratios, the short leg, I'm going to multiply it by the square root of 3 to get the long leg. And now that becomes the height of my parallelogram, okay? So now I could take the base, which was 5. I can take the height, which was 2, square root of 3, and multiply those together. So 5 times 2 is 10, square root of 3. Okay? All right. Let's go down to example number 3. This is a trapezoid. For a trapezoid, the formula is this. Okay, we've done this before, but H stands for the vertical height. B1 is typically the top of it, and B2 is typically the bottom of it, okay? So, or you could call this, this is a rectangle, and this is a triangle. So I could find the area of each and then add them together, whatever you want to do there, okay? But they also want me to get the perimeter, so I got some things I got to find here, okay? First off, if this is 14 right here, then this should be 14, all right? If this is 5, then this should be 5, okay? And they're giving me a clue here. There's a triangle out here, and it's right, and if that angle is 45, then this angle is 45, okay? So that makes this a 45, 45, 90 triangle. This is going to be its hypotenuse. So if this is 5, then this should be 5, okay? All right, and then if I need to find the perimeter, so I got to find the hypotenuse of this. So if you go back to your relationships, it's the leg times the square root of 2. So this is going to be 5 square root 2. Okay, so now I got everything I need. I'm going to go ahead and use this instead. The vertical height of this trapezoid is 5. Okay, base 1 is typically the top, so that was 14. Base 2 is typically the bottom, so that's 14 plus this 5 is 19. Okay, over 2. Okay, so you guys can go ahead and do the math on that one. See what you get. 5 times 33 is 165, and 165 divided by 2, I believe, is 82.5. Okay. They didn't give me any units, so it's just 82.5 units squared. Okay. But they also asked me to get the perimeter, so that's why I did all that work to get all this stuff. So that's just adding up all the sides. Now, the problem is, or the issue is, that I have a number like that, but I don't have any other radicals. Okay, so I'm just going to add up the other sides that I have, and then plus 5 square root of 2. So 14 and 5 is 19, and then this was 19, so 19 plus 19 is 38. Oops. Sorry. P, so 38 plus 5 square root of 2. Okay, I can't put those together by addition because I have a radical and I don't have that in all my terms. Okay, so that's just kind of leaving it in simplified form. All right. Okay, so that was the end of section 2. Just really got to put some time in and study. It's not that hard, but if you don't look at it, you're just not ever going to remember it. It's not going to make sense when you have to really do something. Okay, so study, do your classwork for that. If you got any questions, please ask.